Hello, everyone. Welcome. Thank you for joining us today for Icinga in your observability stack. It's about metrics via OpenTelemetry. I'm Blarim, and I'll be your host for the next hour. I'm not the one doing the heavy lifting today. Our main speakers are Jonas and Alvar, who are both developers here at Icinga. I let them take it from here shortly, but first I want to set the stage a little. So let's get started with why this webinar and why now. So back in April, we shipped Icinga 2 version 2.16. And one of the headline features in that release was native OpenTelemetry support. If you've been running Icinga for a while, the situation today is probably familiar to you. Your check plugins produce a lot of valuable performance data from CPU load, disk usage, memory, network throughput, response times, and whatever. And you've been sending those somewhere which is supported by Icinga 2, like Graphite, InfluxDB, Elasticsearch, maybe the Perf data writer. And those tools work, but they tend to lock your metrics into one specific pipeline. If you also wanted that data in, let's say, VictoriaMetrics or Grafana Mimir, or have them correlated next to your application traces, that meant custom bridges, extra scripting, extra tooling, or just going without it. That's the gap version 2.16 closes. There's a new feature called the OTLP-metricsWriter, and it speaks the OpenTelemetry protocol natively. So the performance data, the metrics your checks already generate, can now flow straight into basically any OTLP-compatible backend, like Prometheus, Grafana Mimir, VictoriaMetrics, Datadog, Elastic, Splunk, and quite a few others, without an intermediate translation layer. The important part, and Jonas and Alva will go deeper into this, it doesn't replace anything in your existing setup. Your checks, your notifications, Icinga Web, Icinga DB, all of that keeps working exactly as before. This feature is additive. It just opens up where your metrics can go. Just a few words about OpenTelemetry itself. For anyone who's heard OpenTelemetry a lot but hasn't had reason to dig into it yet, let me give you a 30-second version because it's the foundation for everything that we'll show today. OpenTelemetry, basically often shortened as OTEL or OTEL, OpenTelemetry is an open source observability framework maintained by the Cloud Native Computing Foundation. I think that the simplest way to think about it is as a vendor neutral standard or a common language for telemetry data, metrics, traces, and logs. Instead of writing a separate integration for every backend you might want to use, you produce data once in the OpenTelemetry format and export it to anything that understands it. And in 2026, that's basically the whole field. The major cloud providers support it. Many observability vendors accept OTLP data. So for an infrastructure monitoring tool like Icinga, speaking OpenTelemetry isn't really a nice to have anymore. It's how monitoring tools are expected to fit together. And that's the context this feature is about. To be precise about the scope, this release focuses on metrics. Traces and logs are not part of it. The feature is called OTLP-metricsWriter quite deliberately to leave room for what might come later. So what's coming in this session? Jonas and Alva are going to walk you through the OTLP-metricsWriter, what it actually does, how to enable and configure it, and then give a live demo taking Icinga performance data all the way through to the metrics showing up in your Icinga web. Along the way, they will cover a few things that matter in real deployments. for example, how performance data becomes proper OpenTelemetry metrics, and how you can export thresholds and enrich metrics with host and service context. With that, handing over to Jonas. Thank you.
Right. My name is Jonas, and I'm here part of the core team here in Icinga 2, working primarily on the core side, and since the last couple of months, fully occupied with Icinga notifications daemon, if you heard of it. This is the next new shiny feature in Icinga 2. Yeah, I'm very excited to be here and share my knowledge with you all, but I'm also a little bit nervous, to be honest, since I'm not used to be speaking to such a huge audience, so please bear with me. I have, this is my agenda for today. I'm going to show you how you can configure the OTLP-metricsWriter feature in Icinga 2 to connect to the OpenTelemetry Collector, Prometheus, VictoriaMetrics, or any other OTLP backend you want to use, and how you can export the check thresholds like critical, warning, etc. as OpenTelemetry-compatible metrics too. And also, I will show you how you can enrich metrics with host and with custom host and service resource attributes to provide more context about the generated matrix if the standard built-in generated from the OTLP writer aren't enough for your use cases. And at last, I will try to give you or kind of demonstrate in a live action how the OTLP metrics writer behaves in HR cluster zones in Icinga 2. And also will give you a show overview how the exported metrics look like on the OpenTelemetry side, OpenTelemetry Collector side. But that's it for today then. And from there, the Alba will take over and show us and guide us how you can use to plot or graph beautiful metrics for in your beloved observability platform. So yeah, I think the introduction part was already done by Blerim. I didn't think of it, but this webinar is all about the new OTLP metrics writer introduced with Icinga 2.16, I think in the last couple of months, and it's used to convert Nagios-like check performance data into OpenTelemetry-compatible metrics and send them to any OTLP backend you want to use, and not just the OpenTelemetry collector. It only supports the OTLP HTTP protocol and not the gRPC. We have gave it a little bit consideration whether we want to use it or not, but since Icinga 2 and its APIs are heavily HTTP based, then it was easy for us to just implement the HTTP based protocol as well. This writer converts each performance data into a gauge metric point, meaning every performance data, these label and value pairs are converted into their own gauge metric points and sent to the same metric stream to OpenTelemetry. But you will show more about this when we are exploring the exported metrics on the OpenTelemetry side. So yeah. When you freshly enable the Icinga 2 feature, I think I have forgotten to prepare a slide for it, how you can enable and disable the feature, but I think we can just hop in right there and do an easy demo there. This is the machine where Icinga 2 is currently installed, and so, and I have already enabled the OTLP feature because I have used it for my previous demo, but I will just disable it first. Sorry. So now if you just run Icinga 2 feature list on your command line, then you should see the OTLP metrics feature right there. If not, then your machine is unfortunately one of these descriptions that we had to explore to exclude this OTLP feature due to required OTLP protobuf compiler versions, because they are too old on some of the distributions like Debian 11 or Ubuntu 20 LTS, and therefore if you are using like Fedora or Ubuntu Trixie, then it should be there. To enable it, you can just run Icinga 2 feature enable OTLP metrics, then it will be enabled. That's it. You don't have to do anything else. Just restart. Just don't forget to restart your Icinga 2 service afterwards. If you are using the OTLP collector running on the same machine as the Icinga 2 service, then you can basically just start Icinga 2 service and it will just work out of the box without any configuration adjustments, because all the default values have a sane value optimized and also set to work with the OpenTelemetry Collector. Therefore, otherwise, two configuration options I want to highlight here before moving on is the port and the metrics endpoint configuration options here. Wait, I have to switch to my slides again. Sorry. So these two options here, they are why I'm highlighting these two options is because if you want to switch every time to any other backend or OTLP backend, then you will always need to adjust only these two and maybe also the third option, the host option. But every time you need to switch from Prometheus to, for example, Grafana Mimir, then you have to change the port option here to the corresponding port, listener port, and the metrics endpoint of the corresponding OTLP backend you are going to use. And this one is set by default to the OTLP metrics endpoint of the OpenTelemetry Collector. And how this all looks like with the Prometheus OTLP receiver is like this. As I already mentioned before, I have just to change the port to the corresponding OTLP receiver port, and the metrics endpoint is also always different depending on the OTLP backends. And just for reference of to see the difference, they are always different, because I have tested a bunch of OTLP backends thus far, and all of them have their own OTLP metrics endpoint. So make sure to read their documentations before using or configuring the OTLP-metricsWriter here in Icinga 2. And just like Prometheus OTLP receiver for VictoriaMetrics, also you just have to change the same two options, and that is these are port and metrics endpoint. And as you can see here, this one is for the for the Prometheus receiver, and this one is and is commented out, but this one is for the VictoriaMetrics, and and this one also has its own metrics endpoint. I don't want to list yet every other OTLP backend that support to directly ingest OpenTelemetry metrics, but you get the idea. If you want to use a different OTLP backend, just remember to adjust these 2 or 3 options to match the endpoint or the TSDB you want to use. So yeah. As we have covered now the basic configurations and how to configure to connect to different OTLP backends, now let's move to the real and also interesting part of my slides, I guess. And that is exporting the thresholds, check thresholds as OpenTelemetry metrics as well. By default, they won't be converted and sent to the OpenTelemetry backend because mostly they are, I guess, use case dependent, and we didn't want to enable them by default because these also require some storage on the TSDB side, and therefore you have to opt in if you want to stream and convert all the thresholds like warning, critical, etc. And if you set this option here to true, then this writer will stream all the individual check thresholds of the corresponding performance data into the state check threshold metric. And how this all looks like on the other side of the OpenTelemetry Collector, we will be seeing at the end of my slides. But for now, just remember both the perf data and the check thresholds will be streamed into 2 different and distinct OpenTelemetry metric streams. But they are of the same type, of course, and that is gauge, because there is no other data point type currently supported in the OTLP-metricsWriter in Icinga 2. So yeah. Next, let's see how you can enrich metrics with host and resource attributes to give more context and more metadata to your exported metrics. And that is, before that, let me say by default, Icinga 2 or this metrics writer will always include the host name, the service name if it's a service check, and the command name always, without you having to configure here additionally. But if that's not enough for you, then you can of course provide more context to the exported metrics, and these will be included as the source resource attributes of each of both metrics the OTLP writer currently supports. These both options are of type dictionary, meaning they are a key value list, or you can provide a key value list via pair list, sorry. And of course, they also support Icinga 2 macros, meaning if you are already familiar with Icinga 2, you might already know how this all works. But if you don't want to hardcode any values here, you can just use Icinga 2 macros, and the OTLP metrics writer will dynamically populate or resolve this host was env, for example, reference it to the from the corresponding host that is being currently processed. For example, I am referencing here host was env, and if the host check result or if the check result for which the OTLP metrics writer is currently processing have these customer defined, then it will resolve it automatically and transform it into resource attribute. But if not, it will not error out, but just ignore it silently, because this is not an error file, or it is not like you must, if you configure, for example, it's optional. If you know what I mean. Host vars, the custom vars are all optionally. If they resolve to something usable, then they will be used. Otherwise, they will be skipped silently. But one thing you have to note about the macros is that currently we only support scalar types, meaning these macros are not allowed to resolve to, for example, arrays or other objects, because even if OpenTelemetry currently supports much more data types for the resource attributes as well, but the OTLP-metricsWriter currently supports only the three scalar types, and these are strings, numbers, and booleans. So if you need to, if you have use cases for arrays and dictionaries or any other complex types, then maybe you can open a request on GitHub or somewhere else. Then maybe we can discuss if we need to, implement the support for these data types as well. But for now, we only support the scalar types. Finally, let's see how the OTLP backend, OTLP-metricsWriter behaves in HA cluster zones in Icinga 2. For those who aren't familiar with Icinga 2 HA, it means if you Icinga 2 HA clusters are usually made of two Icinga 2 endpoints, and you usually have to enable each writer, for example, the OTLP-metricsWriter in this case, on both endpoints. And if this option is set to true, which by default is, then Icinga 2 will pause on one of the masters, this OTLP-metricsWriter, meaning they won't write in parallel the same data or metrics into the configured backend, but only a single OTLP-metricsWriter will be active in any given time. As long as it is functioning perfectly, then the other one will just be in a standby mode and won't do anything. Just But if you set it to false for whatever reasons, they will kind of act as split brain scenario, and they won't have they won't know anything from each other. Therefore, they write in parallel everything they get and transform the metrics and send it to the same OTLP backend, which may or may not result into duplicates, which I think we do not want to happen. So to demonstrate this, before this, how this HA failover takes place is a little bit tricky if you are, especially if you are not familiar with Icinga 2 JSON APC connections. But even if the active OTLP-metricsWriter cannot connect to the configured OTLP backend, then it won't happen a HA takeover or failover, because the HA takeover mechanism is dependent on the JSON APC connections, which Icinga uses since the early days of Icinga 2. So meaning as long as the JSON APC connections between the two Icinga 2 endpoints is healthy, then there will be no HA takeover for this OTLP-metricsWriter, even if the active one cannot connect to, for whatever reasons, to the configured OTLP backend. And for this, I want to simulate here using IP tables how we can let me quick. So I have a simple master setup here in my testing demo. And currently, as one can see here, the active OTLP metrics endpoint is on master 2, as it's logging here successfully connected to the OpenTelemetry backend. But the OpenTelemetry backend container is running on the machine where my master 1 is also running. And therefore, I can just do IP tables, add IP tables filter to drop the packet. Yes, exactly this one. So I think it takes a little time before it. So yeah. Something is really wrong now. Let me see whether I've added the correct filter here. Yes, it is. But for some reason, the failover or the error here, we can't see the error on the other endpoint. Yeah, never mind. Let's continue before we overstretch the time here. Just remember, it's dependent on the HA or JSON APC connection between the two endpoints, not the connection between the OTLP-metricsWriter and the OTLP backend. It's configured to connect to. Even if it can't reach the configured backend for 1 hour, it will just keep retrying as long as the connection between the two endpoints is healthy. So yeah. Okay, next my final slide is this one here. We have covered how you can export and also enrich your metrics with your with a bunch of additional context and all of that. But we haven't seen so far how the exported metrics look like on the OpenTelemetry Collector side. And for this, I have just prepared a simple curl command here, which will provide all the exported metrics in a Prometheus compatible format. And that is basically the same endpoint my Prometheus instance is also currently using to scrap these the metrics originating from the OTLP-metricsWriter. And for that, I can just run. So I hope this is big enough so you can read something. There are only 2 metric streams currently supported by the OTLP-metricsWriter, and these are one is this one here, state check perf data, and the other one is state check threshold here. If this one will be only available here if you enable if you set the enable thresholds, send thresholds option as demonstrated in one of my previous slides. And as one can see here, the Icinga 2 command name is always available, and also the host name and the service name. If it's a service name, if it's just for a host, then the service name will be omitted entirely. Yeah, it will not be visible here for host metric streams. But since this is for service, I think I have also provided for host, but it seems to be gone now. But yeah, And the same goes to the state check threshold metrics stream. It contains the same command name as in the other metrics stream, the same host name, the same service name, but also two additional labels or attributes that is unique to this metric stream, and these are perf data label and threshold type. These correspond to the perf data label you are this data point belongs to, and the threshold type, which can be either critical, warning, max, or min, as you can see here also for the other threshold types. If there is no defined thresholds in Icinga 2, then there will be also no metric points here in the exported metrics in OpenTelemetry Collector. And yeah, I think that is all I had for today. I really wanted to show you with this IP table filter, but if somehow it didn't work, so yeah. I will hand over Alba to Alba, which will show us how you can plot from these exported metrics to in Grafana or Prometheus, and also render a really nice dashboards and also graphics like never before. So thank you.
Okay, thanks, Jonas. I'm going to take over now. I'm just going to share my screen, and I hope you should see it now. Otherwise, please feel free to interrupt me. So, I think thanks everyone from my side for being here, and thanks to Jonas for the first part. I am for myself also a software developer at Icinga in the same core team as Jonas. We're colleagues. And while Jonas did most of the OTLP implementation on the Icinga side, I did a bit of testing and tried to integrate it with other tools I used before when working on system administrations. So I'm having here a test setup as well. It has a web component we're getting into later, and the good old Icinga on the command line. So at first, we're checking if it's available. It is available and also enabled here under OTLP-Metrics. So we are going straight into the configuration. In here, I have two OTLP-Metricswriter configured. First, the OTLP Collector, which we're going to take a look at first, and later on Prometheus, where it's OTLP backend. So the OTLP Collector is some kind of central metrics hub where you can send in metrics from different OTLP metrics from different sources, and the OTLP Collector can filter it, can transform it, and can forward it to other sources. As for example, you have seen earlier in Jonas' demonstration where he used it as a Prometheus-compatible endpoint. So in this case, I'm just having here a very trivial OTLP configuration. That's everything, actually. I'm having configured a listener, which is then binding on the same address where Icinga is going to connect to. Then I'm exporting it. I'm not really processing it because it's just for demonstration's sake. For one side, I'm just logging it in the syslog to fill up my disk space. To fill up my disk space even further, I'm writing log files, real log files on my var log. Those are then rotated. I can use those logs via JSON. We'll take a look at them later for whatever I want to, because now I have logs based on the metrics data. And because it's just there, we also have a Prometheus endpoint. For example, we can just open this file, and yeah, we see it's, well, a lot of JSON. I'm going to close it before my Vim crashes. But we can also tail on it. And now we're seeing lots of metrics. These are the metrics we know from Icinga, but now we have them in this generalized form. Is it really useful? Well, it's logs. We can process it with our own tooling because now we have JSON, and JSON can be consumed by everything. But more prominent would be the Prometheus compatible endpoint, which I'm just curling here, as you've seen earlier at Jonas. This is the OTLP Collector, which can do lots of things. I would invite you to check out its documentation because it has under processors over here, it has filter capabilities, so you can drop some metrics you don't want or only forward some services. But I'm going to focus today on an integration into another backend. I've chosen here Prometheus because I'm quite familiar with Prometheus, but you can exchange this for VictoriaMetrics, Mimir, or similar backends, or on the other hand, with any OTLP-compatible backend, which might work on other way, like OpenSearch or Elasticsearch. Starting at the configuration, these are the default Prometheus ports and on the localhost. Then it has this metrics endpoint, which needs to be enabled. In this case, you have this way. You have to give a flag to Prometheus. In this case, this is the enable OTLP receiver flag. So in this case, I'm starting it via systemd. I've just passed this flag. If you use another service manager or some Docker container, configure it over there. Then Prometheus, the Prometheus daemon, accepts OTLP metrics in the HTTP format. I'm also sending the thresholds here. So I'm not only sending the pure metrics, like for example, if I'm having, let's go over here at Icinga DB. If we're having some load, I'm not only sending the load values, but I'm also seeing the thresholds like the warning and the critical. We're going to this later. And I'm also adding some additional attributes, the locations. Jonas talked about it earlier. And at the second demonstration, I'm going to show what we can do with this. Now, for the Prometheus side, the configuration is kind of trivial. It's in this case, Prometheus is the setup only used as a data sink. It scrapes itself, but this could even be removed. And more important, for the OTLP configuration, I'm listing these resource attributes I'm interested in, because otherwise Prometheus wouldn't care to index this. And there's the Icinga 2 hostname, service name, and command. Those are sent by the Icinga 2 OTLP-metricsWriter and now are available in Prometheus. And furthermore, our custom, those are the custom attributes with an error, host location. These are these two. So far, I've shown a bit of configuration, but configuration itself is boring. So let's switch over. Now we're having an Icinga 2 web here with the a web module to display performance data. In this case, it is it is the module perf data graphs from Netways with the Prometheus backend, which I can highly recommend because it usually just works out of the box. The graphs you're seeing over here are fetched from Prometheus, the same Prometheus where the OTLP metrics data sends data to. So now we're having some metrics here. In this case, this is the demo host we are looking at, and it's load 1, 5, and 50. But we can also look at it in the Prometheus itself. Over here, I'm having the Prometheus web interface, and I'm using its query language to filter for this very service. Let's have a bit of our history. And now we're seeing here the load 1, 5, and 15 of the service itself. Otherwise, we can just broaden this because the demo setup was in the demo host. And now we have this very useless graph where it's all over the place. So just go and ignore it. Now, we have this load and we have it in the Prometheus. So what can you do with it? We have Prometheus as a time series database. So we can put 2 queries onto it. For example, we can extrapolate. Load, I think, is a nice example for this because load can rise and fall. All of you have some night shifts, might know if your smartphone starts ringing because the load goes up, and this is something which you can't predict under some circumstances. So we're going over to here, and here I have a Prometheus query which predicts load. In this case, it does a linear prediction, like it's extrapolating the current load. I mean, we're checking the load. It's the same query we saw over there in the Prometheus Query Explorer. We're getting the load 1, that's like the load of the last minute, which is quite volatile for a certain host. In this case, the webinar host. And then we're extrapolating the last 10 minutes to an hour. So if we have a raise in the last 10 minutes, then it shows us how it would look in an hour if it just keeps raising. And because we have a demo setup, we're just going to put it under some stress. We're starting the stress command. So our load is going to rise. We just let's do it this way. The font is a bit big. So we're just seeing the load is rising now. We're now at load 5, and so on. We can go to the Icinga check. It should be rescheduled every 30 seconds, I guess. So yeah, so in a few seconds, it's going to reload by itself. Oh, and now we're seeing, oh, okay, now it's just warning, not critical, okay. Because now it's 8, we see it's, well, it has risen. Just going again. Now it's critical with 11, and we're seeing here in the small graph, it's going up. So now we can go to the linear extrapolation and run this query. And now we're saying, oh, if it keeps rising in the same interval as risen before, in an hour, we put in at like 14. But if we're just going to rerun this query in a few minutes, because we're going to look at the last 10 minutes, it's going to be way up. So now we have a possibility to get information from our checks, which were before like state-based, and at this time possibility. Like in this case, we can do a simple time series database query. How would it change this value if we just extrapolate it? Of course, extrapolation is a bit of a, well, it might not be the best thing because it has some shortcomings, but it gives us a good feeling. For example, now, okay, we would go to the moon. I'm going to just stop the stress to let the load fall again. And with this, I would go to the next example, as I foreshadowed earlier. I'm adding this location information. So we're going back to Icinga Web. And here I have some hosts. These hosts are just like, well, it's a demo setup, obviously. Just considering 3 data centers, we have Fürth 1, we have Nuremberg 3, and Nuremberg 4, just sorted by name, that makes more sense. And click the wrong host, obviously. And in these data centers, well, obviously we have a gateway for each, and then some servers. Each one has its own IP range. Like those are these. We have some, well, I mean, it's all mocked, obviously, but at least the networking works. So, and then just considered, well, we're having this location, which we're sharing in HMetrics, and which we are going to see here as well. We're just looking for location. We see here each data point has a location attribute. In this case, it's what we inferred. Okay, so we can do some queries on it. In Prometheus, we can aggregate on labels as well. So we can just check, for example, how are the average ping, for example, in those areas. So then go over here. I'm going to my dashboards, and I'm having a location overview. And here, at first, I'll just say, let's put Fürth down. I'm adding an IP tables rule here, which just randomly drops packages for the subnet of Fürth. Oh, now my battery starts dying. Wonderful. It was fully charged before I started. Nevertheless, and here I'm aggregating by those host location and checking all these data. So I'm just going to reload it. Just going to. Oh no, here it starts failing. We see at first there's suddenly package loss, obviously, because we start drawing packages. And now seeing in our dashboard. Bam, we've got an average package loss for third because, going back to the query, sorry, I was jumping a bit back and forth. We're getting the average package loss for grouped by the location. In this case, our location was third. So we see everything else is green, third is red. We can do similar things on location, for example, to get some topmost. In this case, those are the most loaded servers per location. That's the top key query, and which we could use, for example. It's similar. You just have to get yourself a bit comfortable with the query language of your time series database. In this case, it's Prometheus, and then you can extract information based, time series information or numeric information based on the states you have earlier in Icinga. Now, to just stop it, we just use the FP table thing. We remove the the package loss, and shortly it should just drop again. Just search for first name as ping. No, that's the wrong ping. Let's take ping 6. Okay, it's also recovering by itself. So now we're seeing the average packet loss is already falling. It's falling further, and in a second it should go back to 0. So this was just a small demonstration of what is possible if you have OTLP backend, which is now a time series database. This is Prometheus, and integrated with the checks you already have in Icinga. So you have another dimension where you can just put in queries and distribute your data even further. And now I think we just have 10 minutes left, so I would close a short, hopefully motivating demonstration to get back to the Q&A.
Yes, that was perfect in time, actually. Thank you very much. During the session, I've collected a bunch of questions, and I would say we just go through those where I believe they fit most for this session. We had a couple of questions that are not related to this feature at all. I would either move them to the end or skip them entirely. Let's see how much time we need. I would like to start with something that we just recently saw at Alva's presentation regarding the labels. What is the limitation of the transformation between custom variable content into labels? Is it possible to also transmit more complex custom variable data types like arrays or dictionaries? Or are we limited to booleans and strings?
Currently, as already mentioned before, the OTLP-metricsWriter is only limited to these 3 data types. These are strings, numbers, and booleans. But if you have a use case for such complex data types, then maybe you can just open a request on GitHub, and we might be adding that feature too in the future.
Right. I think this question came from Rocco, who we know very well. So Rocco, feel free to reach out if you have any use cases for this. Moving on with the OTLP-metricsWriter. So let's assume that the connection between the metrics writer and the receiver, whether it be the OTLP Collector or Prometheus or whatever, let's assume that the connection is interrupted. What will the metrics writer do in that case? Will it buffer the metrics? How long will it buffer them? Is it an option that we can set? Or will it just fill the memory until Icinga 2 crashes?
That's exactly what would happen right now. It will just buffer all the accumulated metrics until it either successfully reconnect to the OTLP backend and flush all the collected metrics, or Icinga 2 goes out of memory and would be killed by the kernel, and you will, of course, lose all the accumulated metrics in that case. But if the OTLP backend it is used to connect to recovers in the meantime, then all the buffered metrics will go straight. They should do. Also, nothing will be lost in this case.
Right. All right. Alba, we've seen during your demo that you used the OTL collector as a backend. Can I run the OTLP-metricsWriter in parallel as well, like I could do with a collector?
Well, I mean, the OTLP-metricsWriter, it's the thing in Icinga, which sends the metrics anywhere, and the OTL collector, well, collects things.
I should be more precise. I'm sorry,
Okay,
I should be more precise. It's about running the OTLP-metricsWriter in parallel in order to have a transition, maybe from an older or from an existing writer like Graphite writer or InfluxDB writer. If I want to transition from an existing writer to the new one.
Yeah, I mean, nothing is stopping you. Just seen in my short demo, I ran 2 parallel OTLP writers. You can, of course, have your InfluxDB writer, Graphite writer, or whatnot writer parallel. Maybe the indices are quite different. So if you have your old dashboards, you eventually have to remap some labels, or just to have to adjust your dashboards. But yeah.
Mm-hmm. Okay. So maybe one for the roadmap. There was a question regarding how we want to move forward with this. The question was if there's something planned that is similar to OTLP-metricsWriter, but for logs and events, in particular about sending events like this host or this service went into this certain state. So right now, the OTLP-metricsWriter has just recently been released. It's just been a month or two. For us, it's the first release with related to OpenTelemetry. I think we are still learning on how it can help us. We will have to see how the adoption rate is. We will have to see how the feedback from the community is, from the customers, what we can learn about additional OpenTelemetry features. I would not exclude forever that we will do a OTLP events writer, perhaps, if there is a real use case for it. However, currently there are no specific plans to do so. So I would leave this open for the future, and let's see first how this feature will be adopted and how useful it will be for the users using Icinga. Then maybe one more question regarding the protocol that we're using. The OTLP-metricsWriter uses HTTP. Are there any plans or reasons why we are not using gRPC protocol?
I think I have already mentioned the reasons why we have picked the HTTP protocol over gRPC, because Icinga 2 and its APIs are all HTTP based, and that was kind of obvious and easy to implement the HTTP based protocol for the OTLP-metricsWriter too. But if you really need the JSON RPC based protocol as well, then maybe you can open a request on GitHub too, and maybe we will see then how we can integrate it into our Icinga 2 code bases. But I can't promise you anything.
Right. Let's come to the last question for today. If there are any pre-built Grafana dashboards available for these metrics, and I think I can answer that myself. We currently don't provide pre-built Grafana dashboards for this metrics writer. Reason for that is pretty simple. We didn't have the demand for it, but there's also in each setup it's different. So there are a couple of default checks that run in many setups. However, since the OTLP-metricsWriter is built to work with many different backends, we have a high dynamic setup here, because we have dynamic plugins running on the environment, so we do not know which kind of plugins the users run, and at the same time we don't know which type of backend they are storing the metrics to. So providing default dashboards for this is quite a difficult task, which we currently don't do. With that said, I would say thank you very much to Jonas and Alva for providing this content today, for sharing your knowledge and learnings from this feature. Thank you as well for attending this session. We will end up here. Thanks a lot, and see you in one of our next webinars. Don't forget to tell your friends and family about Icinga. Bye-bye.